All right, today we're looking at FRQ number 10. Okay, so let's just go ahead and jump right in. So, solutions to the differential equation dy over dx equals x times y cubed also satisfy that this should be d2y over dx squared. So, essentially, this is the derivative. This is the second derivative. We know that that's true. Let y equal f of x be a particular solution to the differential equation. So f of x is the solution. dy over dx equals xy cubed. So we can find a solution to this. F of 1 equals 2. So when x is 1, y is 2. First thing is write the equation for the tangent line. Easy enough. Three things we need are x. Well, x is 1. Y tells us y is 2. And slope. Well, we find our slope by plugging that into dy over dx. Slope is equal to dy over dx at 1 comma 2, which is equal to 1 times 2 cubed, or 8. And so we can create our line y minus 2 equals 8 times x minus 1. Easy enough. 2 points available here. 1 point for doing f prime of 1, so the derivative at 1, and then 1 point for your answer. Okay? So 1 point and 1 point. Part 2. This one is a little bit weird and a little bit wordy. So first, let's use the tangent line approximation from part A to approximate f of 1.1. So this is y minus 2 equals 8 times x minus 1. And we're plugging in 1.1 to approximate what y is. So y is going to be approximately 8 times 0.1 plus 2. 8 times 0.1 is 0.8 plus 2. So y is approximately 2.8. So we've approximated what f of 1.1 is. Now, the next part of the question is where this is weird. So, given that f of x is positive for 1 to 1.1, is the approximation for f of 1.1 greater than or less than f of 1.1? And explain your reasoning. Now, we need to think about what's happening here. We have some positive function, so it's in the positive area. It's either increasing, it's either increasing or it's decreasing, but we know it's positive. And we want to know, is this tangent line, does this give us an over approximation or an under approximation of f of 1.1? Let's see what this means. We actually have two cases here. Let me just erase. Let's think of what happens when we have a tangent line. We have a point, and the tangent line goes just through that point. So what we're saying, if this is f of 1, and right here is f of 1.1, we're trying to figure out, when we use this tangent line to approximate, is it going to be above or is it going to be below? So we need to think about the shape of graphs, and we need to figure out what aspect of the graph will tell us that. Well, if we look at this one, it's increasing, or increasing and kind of concave down. Here's increasing and concave up. Here's decreasing and concave up, or concave down. And here is decreasing but concave up. So those are the 4 different ways we have aspects on a graph. Notice how for each of the concave ups, these two right here, the tangent line is an under approximation. And for each of the concave downs, the tangent line is an over approximation. So that tells us if we figure out whether the function is concave down or concave up at f of 1, we're going to be able to figure out what the whether it's an over approximation or under approximation. In other words, we're going to be able to figure out, is our approximation greater than or less than actual f of 1.1. So that means all we have to do is figure out whether it is a concave up or concave down function. Well, that's where they give us this one piece of information that is only used for this part. They tell us that the second derivative is y cubed times 1 plus 3x squared y squared. Now, we could have found this on our own, but they give it to us. We're going to use it. So this means that we can use this to say, okay, if this comes out positive, we have concave up. If this comes out negative, we have concave down. So let's plug in our point. Let's do d2y over dx squared at 1, 2. And let's see what happens. So we have 2 cubed times 1 plus 3 times 1 squared times 2 squared. We don't really even need to know the number, but we can just look at this and say, oh, this is greater than 0. So we know that this is d2y over dx squared is greater than 0 at x equals 1. So the approximation for f of 1.1, and we said earlier, since it's concave up, this will be an under approximation, is less than f of 1.1. A lot of work, and honestly, going to be a pretty weak payout. This is actually only 2 points. 1 point for your approximation, and 1 point for all of this explanation. Now, you've been keeping count in your head, and you notice we have 2, 2. That means we only have one more part. This is actually 5 points right here, finding the particular solution. And you'll notice any of these differential equation problems usually have the most points at the finding the particular solution. So this just becomes a general integration problem. Separation of variables, all of that good stuff. So, separate the variables. We'll move dx to that side, y cubed to that side. So 1 over y cubed dy equals x dx. We'll integrate. Integral of 1 over y cubed is negative 1 over 2 y squared equals x squared over 2 plus c. We need to figure out what the c is, so let's do that at this point. We'll plug in 1 and 2. So we have negative 1 over 2 times 2 squared equals 1 squared over 2 plus c. And we'll just try and get c by itself. So this is negative 1 over 8 equals 1/2 plus c minus 1/2, so negative 1 over 8 minus 1/2 equals c. 1 over 8 minus 1/2 is the same as saying 1 over 8 minus 4/8. So negative 1 over 8 minus 4/8 gives us negative 5 over 8 equals c. So there's our c. Just going to erase all this. So negative 1 over 2y squared equals x squared over 2 minus 5 over 8. Multiply both sides by the 2. So negative 1 over y squared equals x squared minus 5 over 4. And then we need to try and undo this. So we'll multiply by y squared and divide by this. So we have negative 1 over x squared minus 5 over 4 equals y squared. And now we're going to take the square root. Okay, so we take the square root and we get y equals square root of, I'm going to go ahead and distribute this negative down to the bottom just so it doesn't look like we have a negative in there, of 5/4 minus x squared. And we need to determine, are we going to use the positive square root or the negative square root? So really, we're just going to plug in 1 and see if that gives us the right answer. We know, looking at this, that this should be positive 2, which means we're going to use the positive square root. So this is our final answer. Let's look through all these points. You got 1 point for the correct separation of variable, 1 point for taking the correct antiderivative, 1 point for the constant of integration, 1 point for using the initial condition, so actually plugging it in and finding what the constant of integration is, and then 1 point for isolating y. So 5 points total. As always, give yourself a grade out of 9, submit it online, and ask me questions if you need. Have a great day.